So I want to start talking about system thinking today. So what is a system? What are the characteristics of a system? And then what we'll do is how do we use that knowledge to lead to breakthrough business results? So I'm all about the breakthrough results of trying to get more results than what people believe are possible with the current resources. So not adding investment, not adding people. How do we leverage our current resources to get more through our system? So starting out with system thinking, first we talk about complexity. So I have two diagrams up here, system A and system B. So which system is more complex? So we have system A that has these four boxes, system B has these boxes and arrows and connections. So which system is more complex? I don't know if anyone wants to comment which they think is more complex.
Is it B?
What's that?
Is it B?
B?
Or is this a trick question?
Yeah, you're right, Keith. So a lot of people look at system B and say, wow, that's really complex. There's a lot of boxes, there's a lot of arrows, right? A lot of connections. And so from Dr. Goldratt was a doctor in physics. And so when you look at physics, how do physicists define complexity? Well, complexity is defined by the number of points within a system you need to address in order to affect the performance of the system. So it's called degrees of freedom. So the more degrees of freedom in a system, the more complex the system. So if we look at the system again, given that definition, right? And I look at system A, I got to touch 4 points to affect this system. There's 4 degrees of freedom. But in system B, if I could find the right leverage point and I could change that because I have interrelationships and interdependencies, I can affect system B with 1 degree of freedom. So system B is actually less complex than system A from that perspective. Okay. So when we look at an organization, an organization is a system. So a system is an organized, purposeful structure that consists of interrelated and interdependent processes. So there's relationships between processes and there's dependencies between processes. So what's an interrelationship? So interrelationship is actions in one function can have positive or negative effects in other functions. Okay, so I was doing training yesterday. We were talking about interrelationships. So people making a decision in one department can have negative effects in other departments without them knowing about it. So if I buy cheap materials, because purchasing is trying to reduce the purchase cost, and it chews up tooling in our machine shop at 3 times the rate. Okay, that's an interrelationship. There was a decision to buy the cheaper materials, and the effect is that cheaper material is harder to machine and it chews up tooling. Okay, that's the definition of an interrelationship. And interdependent means one department's dependent on the other. So if I look at my manufacturing process and I have a machining step and then it goes to another machining step, that second machining step is dependent on the first machining step. So I can't complete the work through the second process until the first process completes their work. Okay. So when we look at a system, we have all these interconnections and we have inputs and then multiple process steps that stuff go through to create outputs that hopefully meet our customer requirements. So every system is a combination of different processes, and multiple processes make up an organization. All organizations can be described as a system. So if you want to learn more about systems, so Dr. Goldratt, all his theories and everything are about system thinking. There's a guy I've been watching videos from recently called Russ Akoff. He was also a systems thinker. I would say that Deming was also a system thinker, but he was really known for total quality management. But again, he was looking at it from a system perspective. So when we look at organizations from a system perspective, we see different things instead of a bunch of just processes that we do, right? Because we have interrelationships and interdependencies. So of course we want to understand where's the leverage. So what is leverage? So leverage is the force that is applied to an object when something is such a lever is used. Okay, leverage is the ability to influence situations or people so you can control what happens. So if we feel like we're out of control, how do we get in control? We need to understand where can we apply some effort to get the system back in control. And I see a lot of times in problem solving. So when we don't do good problem solving, we put Band-Aid solutions in place, the problem comes back. So when we have problems, the leverage is to get to the root cause. If we fix the root cause, then of course we eliminate the problems, but sometimes we eliminate a bunch of other problems because one problem creates another problem, which creates another problem, which creates the effect that we're seeing. And the effect is the symptoms, right? So we don't want to deal with the symptoms. So like when we're ill, we go to the doctor, oh, I got a headache, my stomach hurts, right? And I got a pain in my knee. And so the doctor says, well, I'll give you one medicine for the headache, one for the stomach ache, one for the pain in your knee. It's like, no, what's the cause of the symptoms? And then he prescribes a solution that hopefully solves the cause. So we need to do the same thing in the organization. When we're looking at leverage, where can we make a change? It's going to have positive impact for the company. And probably the number one thing I see companies are poor at is proactive problem solving. They put a lot of Band-Aid solutions in place and they create a lot of non-value added stuff for other people, and it doesn't solve the problem. So the training I was doing yesterday, we had lots of discussions about that. So they had an issue where they had some testing that had to be done through the process, and they had a product that got to the customer, they didn't run the test. So they're like, okay, so now our new policy is you're no longer allowed to package any product until all the tests are done. So they didn't solve the problem of why the test wasn't done. They just put another policy in place to stop people from working. And so now they have all these products in shipping that they can't package because someone's got to go through the validate if the tests were done or not. To me, it's just another non-value added step that's causing disruptions in the flow and not solving the problem. Okay. So in system thinking, a leverage point is a place where we can apply a solution that results in improved performance for the organization. So it's not an improvement to that department. It's not an improvement to that process. It's an improvement to the organization. So a leverage point is where a small amount of effort can create large change in organizational performance, also known as the constraint. So you know me, you know I'm all about constraints and focusing on constraints and making sure we can improve the performance of the constraint. So when we look at different plants, different companies, there's 4 basic plant configurations. So the plant configurations are V, A, T, and I, okay? So the V plant configuration, the characteristics of a V plant, it has many divergent points. So you see the V configuration here. So it starts out with very few raw materials that go through process steps. And then once I go through the process step, I can't go back, right? So Heath will understand this one. So powdered metal plants are V plants. So they start with very few raw materials. They might mix the powder into different configurations. Then they form it into a part. Then it goes through a sintering oven where they can do different things after that, like heat treat, coating, different machining, right? And then they end up with a whole variety of products they offer to the market. That's probably the simplest solution, simplest concept I've seen for a V plant are powdered metal companies. So I start out with different types of powder, and then I end up with a whole variety of products I can offer to the market. Okay. So that's the characteristics of a V plant. But once a path is chosen, you can't go back. So it's like, oh, I got this powder and I mix it to a certain configuration. It's like, oh, I shouldn't have mixed that one. I should have mixed a different one. Too late. I can't unmix the product. Okay. Then once I form it in the press, I can't go back and form it into something else. Okay. Plastic injection molders could also fall into this configuration where I have plastic resin I buy, and then I can mix it with color, and then I can form it into something, and then I can do different activities after it's formed. I can do assembly and stuff like that. Okay, everyone understand the V plant configuration? Okay.
Morning.
So a V plant configuration is, hey Alex, I see Alex just joined from Peerless also. So a V plant configuration is a one-to-many configuration. So I have one material that I can make many components out of. Okay. The next plant configuration is a plant. So a plant has assembly or convergent points. So these are divergent points where I go from one to many different points, divergent. And this is convergent where things come together and have to be assembled. Okay. So many different parts are needed for the same assembly, often produced by the same production departments. And starting with many raw materials, I go through convergent points, ending up with few end products. Okay, so I worked at GE making locomotives. They're an A plant. So I have all these components to make a locomotive, and then I have the cab assembly, I have the frame, I have the engine, right? That go through different process steps, and then they come together in assembly, and I end up with a locomotive. Okay, so a plant structure is known as a many-to-one configuration. Boeing, for example, a plant. So Heath's products in terms of presses are probably like an A plant configuration, right? I got many components to make the press. It goes through similar manufacturing departments, and they go through sub-assemblies, and then I have a press I offer to the market. Next is a T plant configuration. So T plant is almost every manufactured part is required by more than one assembly, and then almost every assembly requires more than one manufactured part. And dedicated production lines are utilized to manufacture each component necessary for the assembly. So I worked at Cummins. Cummins is a T plant. So they have a line dedicated to machining blocks. They have a line dedicated to machining heads, right? And then when it gets to assembly, every engine has a block, every engine has a head. They add other components at the assembly process to configure that to the customer's order. And then they buy outside purchase parts and so forth. And so they have these dedicated lines that, and they have a cam line. So they have a line that makes cams, a line that makes cranks, right? All those come together. And then they put all these features on at the final assembly to make a whole variety of engines for the market. So products are configured to the customer requirements in assembly. And a T plant is a many-to-many configuration. Okay, then the last one is the I plant. So the I plant is where we have a transfer assembly line with different functions all tied together. So the configuration where product flows through the same sequence to make finished products. So like an assembly plant. So like the assembly plant for Harley Davidson is an I plant, right? Once that's set on the line, it goes through the line and components are added to it. Tesla's manufacturing assembly plant is an I plant. Most automotive assembly lines are an I plant. The brewery I worked with is an I plant. So I start out making different products, and when I package it on the line, it goes through the sleeving operation, then the filling operation, then it goes through a testing operation, then it goes to our cartoner, packaging equipment, pallet, and done, right? So all the operations are tied together, and there's similar raw materials, work in process, and finished goods with similar run times and setup times at each step. So doesn't matter what product the brewery's making, if they're canning beer or canning a seltzer or canning a ready to drink mix, the line runs at 18,000 cans an hour. And if the filler station stops, the whole line stops. Okay, so that is known as a one-to-one configuration. So we have one to many, many to one, many to many, one to one. So all companies fit into one of those four plant structure types. So what I came up with was I have these four plant configurations, V, A, T, and I, and then I have different order types. So I got make to stock, make to order, configure to order, or engineer to order. Okay, so now I take these plant configurations and I match it up with my order configurations. And so I come up with this 16 box matrix. Okay, so every organization out there, manufacturer, can be fit into this 16 box matrix. So when people say we're different, yes, I agree. You're one of 16 different configurations. So I recently worked with a company that's a make to stock V plant. Okay, so they make their products to stock and they start with very few raw materials that go through divergent points and they end up with a whole bunch of variety of end products. And so people that seen the case study, it's Channel Lock. Channel Lock's a make to stock V plant. And then when I worked at GE making locomotives, they're a configure to order A plant. Okay, and then the other dimension I added here, I added a third dimension of mix. So I have some companies that are very low mix and some that are very high mix. So the higher the mix, the more variability there is in the process. Right, so it's like I can do some really small stuff to really big stuff, right? That's variability in the product mix. Okay, so think about your organization where you fit, and you might have multiple. So I think Fearless that's on the call probably have multiple environments, right? And so that's a little bit more challenging when we have multiple. And I think Heath at Gasbury has multiple configurations, right? And then we can have combinations of the plant types. So we can have a V base with a T top, and A base with a with a T top. So there's all these different configurations that can be a combination. So I also worked in furniture manufacturing. So when we have furniture that we make, so it's sort of a V at the bottom. So I take a piece of wood and I cut it and I shape it and I route it and then all this stuff. And then I have to assemble it into a dresser. So I have a V at the bottom, but the assembly process is an A where I offer that product to the market. Okay. Any questions on that? That's what I wanted to cover today. We're gonna have a quick discussion about it. Next session, we're gonna talk about the unique problems in each of those configurations and then the common problems between those configurations. Questions, comments?
I don't know, CJ, you think we're a make to stock V?
That's what I was gonna, I was gonna ask Max. I mean, you've been here a few times, know our business. That's where my head is at, but
Yeah, I would consider you guys a make the stock V. So Cutco makes knives. So they start out with very few raw materials. They form it, right? They cut it into different things, right? And then they can add different handle configurations and all types of stuff. So they have this very few materials with a lot of end products.
But I think we need to add, CJ, that we're different, all right?
oh, Craig.
Going back on mute.
So I was hoping Marcus was going to be here today because Siemens, they're more of a plant, right? And they're probably engineered to order A plant.
Yeah.
And Heath, your presses are probably engineered to order A plant.
Yeah, and then I was thinking of the contract manufacturing and the automation, so we might have a mix.
Yep, you definitely have a mix.
Yeah.
And then where the real challenge becomes is when I got the same production equipment that's making the products, right, for one configuration and products for another configuration. Is Tony still on or?
I don't think so.
So Max is a lot of the definition here based purely on what's being made and then how it's distributed, you know, what the channel looks like, or do you ever see anybody redefine themselves in this core way, or you are what you are?
No, I think you pretty much are what you are. Because it's really based on the product that you make and the characteristics of that product. And like I said, there's unique problems in each of these. So I'm trying to develop a matrix that says, what are the unique problems in this V make to stock environment versus a, you know, V engineer to order environment.
I bet everybody's jealous of everybody else. Like, oh, I wish I wasn't what I am, right?
So I have worked with roll forming companies. So roll forming companies are again a V. They start with rolled, it comes in a coil metal, right? Then they run it through their machine and they can form it into all different shapes. Typically they're make to order V. They don't typically run a lot of stock. When they get an order for it, it's already been engineered. I'm working with Allegheny Bradford. They're more of a configure to order. I would consider configure to order a plant for some of their products. So they have heat exchangers that are already engineered, but the customer wants a specific fitting in a certain location and a certain connection point and a certain connector, right? So they're configuring that to the order. So what I try to do is, if I understand what the company is, then I have an idea of what problems they're most likely struggling with. If I understand the type of problem, right, I can validate. So I can go and I can have a direct discussion about, oh, do you suffer from these problems? And they're like, yes, how'd you know that? Because I know the characteristics of that environment. Questions, comments? I can show. So I started to put a fault tree together. So a fault tree is basically a diagram that shows the different types of problems in companies and the relationship. So the interrelationships I was talking about. Show that quick. I know some people have seen this. So a fault tree is a top-down method for identifying like what are the contributing factors to different variables in the organization. So if we just take low profitability as a issue that we're dealing with, and what I said is, okay, there's 3 contributing factors to low profitability. One is we have poor margins, 2, we have low sales, 3, we have poor flow. Okay, we could have those 3 things contribute to low profitability. And so when I look at poor flow, what are some of the factors that contribute to that? Well, it's our batching practices and policies. We don't have a good planning process in place. We're asking people to multitask. We have poor inventory practices. We have resource issues in terms of our employees, and we have maintenance problems. So if we just took the maintenance here, what's the reason for poor maintenance? They have too many open work orders. They have lack of standard operating procedures. We see lots of cost overruns and then unmanageable change requests. So it starts to give what are the contributing factors to these different. You can see the scope of it's pretty large. So now when I go back to the plant configurations, we can say, okay, for this environment, what types of things am I seeing? It's like I said, some of them are generic, right? So if I have an ineffective PM program, I don't care what configuration you are, right? If I have an ineffective PM preventive maintenance program, the issues I see are going to be common across every company. We have too many machine breakdowns and unreliable processes. Now, when I go back to the configurations, right, when I have unreliable processes and lots of machine issues, now the implications might be different for these different plants. An I plant, the whole line stops, which is like a huge problem. In a V plant, a lot of times I have alternate equipment I can run on, so it's not a big deal because I just move it to another piece of equipment. In A plant, the problem is that part that I need for assembly doesn't get done, so now the assembly's held up because I'm waiting for the one component that has to go through that machine that's broken down. So the implications of that on the business are different. So we talk about leverage, right? So leverage, if I have an I plant with poor maintenance practices, the leverage is try to get the maintenance practices effective so the line doesn't stop. Where that might not be a case in the V plant because I got alternate methods to produce that work. Poor maintenance practices doesn't have as big of a negative effect on the company. If that makes sense for people. So hence, all problems aren't created equal. That same problem in a different environment can have huge differences in negative implications for the company. So if you bring somebody in that worked in an A plant and you put them in a B plant, the things that they feel are important for what they had in the A plant might not be important for the V plant. So then they start putting initiatives in place that they know from what they did in the other plant, and it doesn't have any impact. So that's why this configuration is extremely important, right? So now it's like, okay, now if I start to look at the problems in different environments have different level of risk. And so sometimes, like when you bring in other outside firms like consultants and stuff, and it's like they worked in one environment and they try to apply the same methods in other environments, it doesn't help because it's a different problem.
Max, a quick question.
Yep.
The theory of constraints and the principles that underlie that, I would think that they lend themselves most aptly or most directly to the T plant. Do you make modifications then for the other ones, I assume? And what does that look like? Or is it a one size fits all? Which
no, it's pretty much one size fits all, but so like when I go back to the V plant, from a theory of constraints perspective, it's probably one of the departments that's a constraint. I have and I don't really have a lot of value streams here, so it's like, I don't like, so you look at powdered metal, there's really one value stream, right? If they have a mixing department, then a molding department, then a sintering department, then a machining department. Pretty much everything flows through that. So it's typically a department is the constraint. Now, when I go to an A plant, it's much different because I could have a constraint in this line. I could have an assembly constraint. I could have a materials constraint. And there's multiple value streams here that feed the assembly. So now how do I deal with those multiple value streams? I could have a constraint in one value stream when I have plenty of capacity in the other value streams. So the effect I would see is like I'm always short in assembly of these components. Did that answer your question, Heath?
Yeah, I think so. Thanks.
And this environment's much more complex to deal with than a V plant. Like, yeah, that's what I wanted to hear, right, Keith? But if we go back to our leverage, right? So where can we apply a small amount of effort to get big results? It depends on what configuration you are and what problems you're dealing with, because all problems aren't created equal. So what I try to do with companies is put in a risk assessment process when we have problems. What is the risk of that problem on our organization? And those get elevated to the top. So it's like we want to focus on the critical few that are important for our environment. And so when I was working with the brewery, maintenance was like the top one because of the I plant configuration. Now, in an A plant, because of supply chain issues, purchasing might be the leverage point. You have a question, Craig? I see you're in deep thought there, it looks like.
Come off mute there. No, just the old life that, yeah, supply that you were talking about, Marcus, the
Yep.
ETO plant, that would, supply chain was crucial. You could have one small welded fitting holding up $1 million train shipment. So.
Yep.
Different beast.
And then again, we go back to the fault tree. Yes, we might have all these issues that we're dealing with, but the impact on the business is different. So due date performance, poor due date performance in an A plant, lack of availability, right? It's a huge issue. Late deliveries from suppliers is a huge issue. Well, late deliveries from in a V plant where I got lots of raw materials doesn't affect me. So a powdered metal plant, typically late deliveries of materials typically doesn't have effect on because they have, storage of raw materials and they don't have to hold 50 different raw materials or 150 different raw materials. And so when I talk about system thinking, right, the problems that we're dealing with, how is that affecting our system? And if we understand where the biggest disruptions in our system are, okay, what's contributing to that? And then where's the leverage point? If we can improve on that element, what effect does that have on the performance of the business? So now all problems aren't created equal. We identify those risks that are highest, we focus on those, and then we were correct, which people are pretty smart in identifying those things. Chance of being correct are pretty high. We get great results. Now changing the behaviors is another issue. So we got to make sure we got the right metrics in place. If we got the right metrics, then we need to make sure we got the right behaviors then. So if the purchasing example I was talking about, if we're measuring purchasing on trying to get lowest purchase price, that might not be the best strategy. So the company I was in yesterday, we were talking about purchasing, and they're like, oh, we have all these supply chain issues, and because of volatility, the price is all over the place. So what we want to do is we want to order materials as soon as possible so we can lock in a price, because their assumption is the price is going to go up. And what's the effect I see? They have their inventories, raw material inventories coming out their ears. They got all their cash tied up in raw material inventory because they're trying to save, money on the increased cost. And I said, well, it depends, right? If I have a product that, for example, I did work with a dental lab. So it's the lowest material cost I've ever seen, 3%. Well, if my material cost is 3%, a 50% increase almost has zero effect on my business. But if I'm a roll former where my material cost is 60%, that's a different story. So I said to them, well, for these different products you make, we need to understand what's the material percentage of the selling price, because that makes a difference on whether we should bring in materials and hold it or when we shouldn't. Because if I see a 50% increase on an item on a screw, who cares, right? The impact is so low on that assembly, right? It doesn't matter. So I started to change purchasing mindset a little bit. It's like, let's look at the impact of those items on the throughput value or the value added, and then make a decision which ones we should be focused on bringing in early and which ones we shouldn't. And then the other question is, okay, if we have a price increase on a certain item, the way to offset that in your organization is increase the flow of that product through your system, because we know that the profitability is a function of the contribution margin, or what we call throughput, and the flow rate. So if my material price goes up, the question I have is, can we improve the flow to offset that cost? If yes, then don't worry about the price variation in the market. And if I have a low material content or low material cost, it's even less of a factor. But that's where we get the misalignment. It's like, oh, we're going to bring in all the materials as soon as possible, so we don't get caught with a price increase. Well, Pareto would say that probably 20% of those items are 80% of the problem. So if we can focus on those 20% of the items and have purchasing closely manage those, and then bring all the other materials in synchronized with the process when we need it, maybe that's where the leverage is. So that's sort of the direction of the solution that we're going right now. But we know from the purchasing perspective, the goal of reducing the replenishment cycle is the direction of the solution. So we want to constantly reduce that replenishment cycle. So the replenishment cycle is from the time we bring materials in till the time we manufacture it, to assemble it, to ship it. We want to try to make that as short as possible. So I think we had that discussion at Peerless a couple of weeks ago, right? So in most cases, reducing that replenishment cycle is the direction of the solution. And then understanding the effect of those items on our system performance. Okay, so that's our session, we're getting close on time. Any other final questions, comments? Is this helpful?